Have you thought of which force holds the human feet firmly on the ground? Which force holds the wheels of a moving vehicle firmly on the road? Which force holds a box that's stationary on the ground? Which force holds it? That's friction, yes. So our discussion today is on friction. Friction is a force that we experience every day in our life, and it's one of the most important forces that makes man's life easy. So what is this friction force? Or what is frictional force? So we are looking at friction. Friction is a force that opposes the relative motion between systems in contact. So if we take two bodies or two objects or two systems, we bring them into physical contact, there's a force that opposes or the force that's acting in between them. And this force is the friction force. It opposes the motion of the force. So if you try to move two objects relative to their surfaces, if you try to rub two objects on their surfaces, the force that opposes that motion is friction. So for example, you are trying to pull or push a box along the surface of the earth, or trying to pull a box on the ground, there's this force that opposes that motion. So that force is friction. And basically there are two types of friction. So we have the static friction and the kinetic friction. And these two friction acts due to the relative motion or due to the position of the object, due to the systems in contact. So this is how these two forces act. So the first one is the static friction. So if you look at this image, the static friction acts when the object is stationary, when the systems are stationary. So when you have a stationary object, that's where static friction acts. And the kinetic friction, it acts when there is movement. If you look at this video, the guy is trying to push the box along the ground. He's trying to push the box along the ground, and the force that is acting between the box and the ground is the kinetic friction. So if two systems are in contact and stationary relative to one another, then the friction between them is the static friction. So if the two systems are in contact and they are stationary, there's no motion, the force that holds the two systems together is the static friction. So an example is when two objects are not moving, static friction acts between them. So if you take this box, there's no motion along the ground, so the static friction is holding the box firmly onto the ground. That is static friction. And if two systems are in contact and there's a motion relative to one another, that is if the box is moving along the surface, as we saw in this video, the box is moving along the surface. So there is kinetic friction that's acting between these two systems, between the box and the ground. So example is friction slows hockey puck sliding on ice. Friction slows the box being dragged on the floor. So as I said in the video, friction slows the movement as you are pushing or pulling an object along the ground. So now static friction is usually greater than kinetic friction. So if you take static friction, since the force is holding the object firmly onto the surface, like the box, the force is holding the box firmly onto the ground, you need much energy to overcome that force, to overcome that static friction before the box begins to accelerate, before there is motion. So always the static friction is greater than the kinetic friction. So as soon as the box starts moving, that is the force you are applying onto the box is greater than the static friction. Therefore, you'll be able to overcome the static friction, hence accelerating the object which is in contact to the floor. So always the static friction is greater than the kinetic friction. And as soon as the box in context here begins to move, then the kinetic friction takes over. That is, this kinetic friction now begins to act between the box and the ground, and the kinetic friction becomes lesser than the static friction, because since there is motion, you need less effort to act on the box to continue with the motion. You need less effort to continue with the motion. So now the magnitude of static friction is the coefficient of static friction times the normal force. So the coefficient is the constant times the normal force. The normal force is the weight of the object. So this expression gives the coefficient or gives the magnitude of static friction. The magnitude of kinetic friction is the coefficient of kinetic friction in the normal. So the normal force is the weight of the object, which is the mass of the object times the acceleration due to gravity, and the coefficient, which is a constant. So this expression gives the static friction and the kinetic friction between systems in contact.